Hello, welcome back to day 2 of lesson 44. Today we are going to look at what happens with rationalizing a denominator when your denominator is a binomial. To do that, we will look at how radical conjugates work. Radical conjugates, if a, b, c, and d are rational numbers, then a roots of b plus c roots of d and a roots of b minus c roots of d are conjugates of each other, and their product is a rational number. So we are going to take a peek at how conjugates work, and I'm going to do that actually with algebra. So if you have something like this, x plus 2 times x minus 2. So one of your binomials is adding, one of them is subtracting, but they're dealing with the exact same two numbers. When you FOIL it out, you'll get x squared minus 2x plus 2x minus 4. But what happens every single time, since one of your binomials is adding, one is subtracting, the o and the I, negative 2 plus positive 2, are going to cancel out. Well, we're going to take a look at that when it happens with radicals. So if you have 2 roots of 3, or 2 plus the root of 3, times 2 minus the root of 3, and you FOIL this out, you're going to get 4. When you do your first terms, plus 2 roots of 3, minus 2 roots of 3. And then we talked about in day 1 that whenever you multiply a root of 3 times a root of 3, you just get 3. Anytime you multiply two of the exact same roots, you just get 3. And same thing, your o and your I are going to cancel out. Cancels, and we're left with 4 minus 3, which is 1. So when you multiply 2 plus the root of 3 times 2 minus the root of 3, it goes back to a rational number. So anytime your denominator has the form a plus the root of b, which means it's a binomial, two terms, you're going to multiply the denominator by a minus the root of b. And I should say the numerator and denominator to keep your fraction balanced. So we'll take a look at example 2, a and b. In part A, I see the denominator is a binomial, negative 3 plus the root of 5. So in order to rationalize, I have to use the conjugate. And the conjugate is just the same numbers, so negative 3 and the root of 5, but I'm just going to make them subtract. So now I've got my conjugate set up. In my numerator, I'm going to use the distributive property. So I distribute, and that's going to be negative 9 minus 3 roots of 5. Okay, there's my numerator. Down to my denominator. Now something happens when we multiply conjugates. Every time your o and I cancel. So in your denominator, that's no different. You got some conjugates there. So we're going to multiply our firsts, outsides, insides last. But a little trick is you don't need to use the outsides and insides because they're going to cancel every time. So I'm just going to multiply the firsts, which give me 9. Negative 3 times negative 3. And then minus the lasts. Root of 5 times root of 5 is 5. So my denominator is now rational. It's going to be 4, but we don't need to FOIL everything out because the o and the I are going to cancel out every time anyway. So final answer then, I'd have negative 9 minus 3 roots of 5 all over 4. And there would be my rational denominator now. 4 is a nice integer and got rid of that radical. And then we'll take a peek down at b. So b, I've got a root of 7 plus the root of 2, so my conjugate would be the root of 7 minus the root of 2. And in my numerator, I got to use the root of 7 minus the root of 2. So just like before, I will distribute, which is going to give us 5 roots of 7 minus 5 roots of 2. Down to my denominator, again, your outsides and insides of the FOIL are going to cancel, so you just need to multiply your firsts, which give you 7. Multiply your lasts. Positive root of 2 times negative root of 2 is going to be negative 2. So again, I'm just multiplying these two together and these two together because I know the o's and the i's are going to cancel. All is said and done then, I'm going to be left with 5 roots of 7 minus 5 roots of 2 all over 5. And here I've got some rational numbers that will start to simplify. This 5 will reduce with this 5. So all in all, we're just left with the root of 7 minus the root of 2. And that would be our final result. So today we're going to look at problems on Delta Math that are similar to example 2. And just be careful when you see a common factor in your numerator denominator that's rational, you can start to simplify that out. So here I have that 5 in the numerator and a 5 in the denominator. We can start factoring those, and 5 divided by 5 gives us 1. But all in all, our final result would be square root of 7 minus the square root of 2. You're now done with lesson 44, day 2, and you are good to go to work on your practice. And thanks for joining, and we'll see you next time.